Hello, this is video 27. This video, I'm going to keep on going over Newton's second law problems, specifically how to work on problems where you have objects on an incline. So, it's only 2 slides in this video. The first thing I want to go over is what we need to do when we see an object on an incline. So the first thing is that we want to rotate our coordinate system. Up till now, we've used a regular Cartesian coordinate system where x is horizontal to the right, positive, and y is positive upward. So whenever you have an object on an incline, you're going to want to rotate that coordinate system. It's kind of like, see how I'm rotating my head so that I'm looking at the incline, and now the incline seems straight to me because my head is rotated. Do you see that? So if you do that, then the direction of the incline is now the x direction, and anything perpendicular to that is the y direction. So if the reason that we want to do this is because it's going to make it a lot easier to work with the forces. So if we had a free body diagram for this object here, we'd have the normal force going perpendicular, we'd have weight going down, and let's say maybe somebody was even pushing this object up the incline. I'm just making this up here. Well, if that's the case, we would have 2 diagonal forces for which we would have to find components, and then the object would be accelerating up the incline, and so that acceleration would have an x and a y component, and that would be very hard to do. But now with the rotated coordinate system, the acceleration is all in the x direction, and so is FA. The normal force is all in the y direction, and we only have to find the components of the weight. Now, I'm not saying that that's the only force we'll ever have to find components of, but rotating the system really makes it easier to deal with the whole problem. So if you do have to find the x and y components of the weight, then here's how you do it. You're going to be given 99% of the time this angle here of the incline, the angle with the horizontal. And you know that if you have your object right here, that the weight is straight down. So the first thing that you want to do is draw those x and y components. You're really going to want to practice this because it comes with practice. Although if you see me do it, it's going to look a lot easier than it is. So the way that you want to draw the x and y components is remember which way your x and y directions are. So if your weight is straight down here, then the x component would be here. It's also drawn up here, but I prefer to just draw it here. This is wx. It's in the same direction as the incline. It's parallel to the incline. And the y direction, you can add a little square here to show that this is a right angle. The y direction, the y component of that weight, has to be perpendicular to the incline. The x and y components, when you draw them on your paper, should be perpendicular to each other. So I really recommend that you practice this. So once you've done that, then you'll realize that the given angle of the incline is the same as this angle here. Now the first time it's nice to kind of see why that is, but after a while you're just going to remember that. But the reason why this is so is because this is a right angle here, since the bottom of the incline is horizontal and the weight was straight down, so that's 90 degrees here. So if this is theta, let's just say 30, just to make it more simple, then that means that this would have to be 60 over here because you have to have 180 degrees in your triangle. Well, these two angles right here also have to add up to 90 because you have 90 on the other side here, and a straight line has 180 degrees. So that means that this angle theta must be 30 to make 90 with 60. So you see that this angle is the same as the incline. And after you do a few of these, you'll just get used to putting whatever angle that you're given here for the incline to just stick it here as the small angle right there. So now we're ready to do our example. So we have an object on an incline, and it's pulled up with a certain force, and we want to find acceleration. We haven't dealt with friction yet, so no friction. We're given the mass of the block. So just to make sure I have enough room, I'm going to do this example here. So let's draw the free body diagram. So we have our box here, and technically the surface is not supposed to be part of the diagram, but to me it helps me put the surface because then I know to draw that normal force perpendicular to that surface. It just makes it easier for me, but technically it's not supposed to be on there. And then the weight of the object is straight down, and then it was pulled upward with a force equal to 5 newtons and 35 newtons, and the mass was 5 kilograms. And the angle of the incline that was given was 30 degrees. Find the acceleration. So we have to separate the x and the y directions. That's the first thing. We're solving a Newton's second law problem. And we want to find the x and y components of any diagonal forces, and we have rotated our coordinate system like we just talked about. X along the incline, y perpendicular to the incline. So we want to go ahead and find the x and y components of the weight, like we just did in the previous example. Now the only difference is the incline is going the other way. No, it's actually going the same way, so it's the same thing that we just did. The weight is straight down. The y component is going perpendicular to the incline, and the x component is going to the left parallel to the incline. And the given angle 30 degrees is right here, that little angle right there. That's why I like to draw my x component here, because then I know that angle is the one across from the x here. And so the x component, as was mentioned in the previous slide, is going to be the opposite component. I forgot to mention this, but you can see right here, the x component will always be opposite this angle and you use sine, and the y component will always be adjacent to the angle and use cosine. So now we're ready to use Newton's second law separately in the x and the y directions. So in the x direction, let's ask ourselves, are we in equilibrium? And we're not, because we're accelerating up the incline. So we're going to write down the forces that we drew. In the x direction, we have the force here, which is positive, and the x component is negative because it's going to the left. So that's equal to max, and I can just write ma because there's only going to be one acceleration of this block along the direction of the incline. The next step was to substitute anything that I know. Now, I don't like to put numbers until the end, but for the x component, for example, I can put mg sine theta because it's the opposite component. And the w, the weight, is equal to mg. So that's what I like to just put in everything that I know and just save the numbers till the end. And from here, what we can do now is we can solve for the acceleration. The acceleration is equal to f minus mg sine theta over m. And now we can just plug in everything that we know. The force was 35. The mass is 5. G is 9.8. Sine of 30 degrees. And you might get used to, I like to use 30 degrees because sine of 30 degrees is 1/2. That's an easy one to remember. Helps time instead of having to put it in the calculator. But now you plug all of this in the calculator, and I got 2.1 meters per second squared. So this is a case where we didn't even have to look at the y direction in order to solve this problem, because it asked for the acceleration, which was in the x direction, and we had enough information. Now, if the problem had asked something maybe about the normal force, then we would have had to look at the y direction. In general, we don't have to look at the y direction unless there's friction in the problem. Most of the time, that's the case, and we haven't talked about friction yet. So that's all for this video. So just to recap, when you have an object on an incline, you're going to want to rotate your coordinate system, find the x and y components of any diagonal force. Usually you'll just have one diagonal force, which is the weight, and in that case, make sure that the x component uses sine and the y component uses cosine, because of the angle that is given is going to be that little one right there. And you don't have to go through all the steps of finding it, you just kind of remember it after a while. That's all for this video.